Hello students, welcome to today's class. Our today's point of discussion is none other than MENDLEEV'S periodic law. In this topic, we will study about historical development of MENDLEEV'S periodic table and classification of elements. Before starting our discussion on it, first let us see what are the learning objectives of today's topic.
Upon completion of this topic, learners will be able to discuss the need of classification of elements, recall and discuss periodic table, define and discuss Duberiner's triads, Newland's law of octaves,
Lothar-Meyer
arrangement, recall and discuss MENDLEEV'S periodic law. Define modern periodic law. Discuss nomenclature of super heavy elements.
What is the need of classification of elements? सन 1800 ਵਿੱਚ ਅਸੀਂ ਲਗਭਗ 31 ਐਲੀਮੈਂਟਸ ਬਾਰੇ ਜਾਣਦੇ ਸੀ, ਪਰ ਮੌਜੂਦਾ ਸਮੇਂ ਵਿੱਚ ਅਸੀਂ ਲਗਭਗ 118 ਐਲੀਮੈਂਟਸ ਬਾਰੇ ਜਾਣਦੇ ਹਾਂ। ਹਾਲੀਆ ਖੋਜੇ ਗਏ ਐਲੀਮੈਂਟਸ ਕੁਦਰਤ ਵਿੱਚ ਨਹੀਂ ਮਿਲਦੇ, ਇਹ ਮਨੁੱਖ ਵੱਲੋਂ ਬਣਾਏ ਗਏ ਹਨ। ਵਿਦਿਆਰਥੀਓ, ਇੰਨੇ ਜ਼ਿਆਦਾ ਐਲੀਮੈਂਟਸ ਦੀ ਪ੍ਰੋਪਰਟੀਜ਼ ਨੂੰ ਪੜ੍ਹਨਾ ਆਸਾਨ ਨਹੀਂ ਹੈ। Scientists felt the need of some simple method to systematize the study of the properties of various elements and compounds. ਹਰ ਇੱਕ ਐਲੀਮੈਂਟ ਇੱਕ ਦੂਜੇ ਐਲੀਮੈਂਟ ਤੋਂ ਡਿਫਰੈਂਟ ਹੁੰਦਾ ਹੈ, ਪਰ ਜਦੋਂ ਐਲੀਮੈਂਟਸ ਦੀਆਂ ਪ੍ਰੋਪਰਟੀਜ਼ ਦਾ ਅਧਿਐਨ ਕੀਤਾ ਗਿਆ ਤਾਂ ਇਹ ਤੱਥ ਸਾਹਮਣੇ ਆਇਆ ਕਿ ਕੁਝ ਐਲੀਮੈਂਟਸ ਸਿਮਿਲਰ ਪ੍ਰੋਪਰਟੀਜ਼ ਦਰਸਾਉਂਦੇ ਹਨ। ਇਹ ਤੱਥ ਪੀਰੀਓਡਿਕ ਟੇਬਲ ਬਣਾਉਣ ਲਈ ਇੱਕ ਮੀਲ ਪੱਥਰ ਵਾਂਗ ਕੰਮ ਕਰਦਾ ਹੈ। Elements having similar properties are grouped together by the scientists. The systematic arrangement of atoms as per their similar properties is known as classification of elements. The systematic classification of the elements has led to the formation of periodic table. Periodic table. Periodic table classifies all the known elements in accordance with their properties in such a way that elements with similar properties are grouped together in the same vertical column. Students, let us study about historical development of the periodic table.
Duberiner's triads
1817 ਵਿੱਚ ਇੱਕ ਜਰਮਨ ਸਾਇੰਟਿਸਟ ਜੋਹਨ ਵੋਲਫਗੈਂਗ
Duberiner's
elements ਨੂੰ groups ਵਿੱਚ classify ਕੀਤਾ। He grouped the elements with their similar physical and chemical properties into clusters of 3 elements called
triads.
He arranged certain elements with similar physical and chemical properties in a group of 3 in such a way that the atomic mass of the middle element was approximately the arithmetic mean of the other 2 elements of the triad. Also, the properties of the middle element were in between those of other 2 members. These groups of 3 elements were called as
Duberiner's triads.
And this generalization was called as law of triads. It's time to discuss some examples of these triads.
Examples of Duberiner's triads. Duberiner's triads ਦੀਆਂ ਉਦਾਹਰਨਾਂ ਨੂੰ ਇਸ ਟੇਬਲ ਵਿੱਚ ਦਰਸਾਇਆ ਜਾ ਰਿਹਾ ਹੈ। ਅਸੀਂ ਇੱਥੇ ਐਲੀਮੈਂਟਸ ਅਤੇ ਉਨ੍ਹਾਂ ਦੇ ਐਟੋਮਿਕ ਮਾਸਸ ਨੂੰ ਵੇਖ ਰਹੇ ਹਾਂ। ਲਿਥੀਅਮ ਦਾ ਐਟੋਮਿਕ ਮਾਸ 7, ਸੋਡੀਅਮ ਦਾ ਐਟੋਮਿਕ ਮਾਸ 23 ਅਤੇ ਪੋਟਾਸ਼ੀਅਮ ਦਾ ਐਟੋਮਿਕ ਮਾਸ 39 ਲਿਆ ਗਿਆ ਹੈ। ਜੇ ਅਸੀਂ ਇੱਥੇ ਪਹਿਲੇ ਐਲੀਮੈਂਟ ਲਿਥੀਅਮ ਅਤੇ ਤੀਜੇ ਐਲੀਮੈਂਟ ਪੋਟਾਸ਼ੀਅਮ ਦੇ ਐਟੋਮਿਕ ਮਾਸ ਦਾ ਅਰਿਥਮੈਟਿਕ ਮੀਨ ਕੱਢੀਏ ਤਾਂ ਇਹ 7 + 39 divided by 2 equals to 23 ਹੋਵੇਗਾ, ਜੋ ਕਿ ਮਿਡਲ ਐਲੀਮੈਂਟ ਸੋਡੀਅਮ ਦੇ ਐਟੋਮਿਕ ਮਾਸ ਦੇ ਬਰਾਬਰ ਹੈ। ਇਸੇ ਤਰ੍ਹਾਂ ਕਲੋਰੀਨ ਦਾ ਐਟੋਮਿਕ ਮਾਸ 35.5, bromine ਦਾ atomic mass 80 ਅਤੇ iodine ਦਾ atomic mass 127 ਲਿਆ ਗਿਆ ਹੈ। ਜੇ ਅਸੀਂ ਇੱਥੇ ਕਲੋਰੀਨ ਅਤੇ ਆਇਓਡੀਨ ਦੇ ਐਟੋਮਿਕ ਮਾਸ ਦਾ ਅਰਿਥਮੈਟਿਕ ਮੀਨ ਕੱਢੀਏ ਤਾਂ ਇਹ 35.5 plus 127 divided by 2 equals to 81.25 ਹੋਵੇਗਾ, ਜੋ ਕਿ ਮਿਡਲ ਐਲੀਮੈਂਟ ਬ੍ਰੋਮੀਨ ਦੇ ਐਟੋਮਿਕ ਮਾਸ ਦੇ ਲਗਭਗ ਬਰਾਬਰ ਹੈ। ਇਸੇ ਤਰ੍ਹਾਂ ਕੈਲਸ਼ੀਅਮ ਦਾ ਐਟੋਮਿਕ ਮਾਸ 40, ਸਟ੍ਰੋਂਸ਼ੀਅਮ ਦਾ ਐਟੋਮਿਕ ਮਾਸ 87.5 ਅਤੇ ਬੇਰੀਅਮ ਦਾ ਐਟੋਮਿਕ ਮਾਸ 137 ਲਿਆ ਗਿਆ ਹੈ। ਜੇ ਅਸੀਂ ਕੈਲਸ਼ੀਅਮ ਅਤੇ ਬੇਰੀਅਮ ਐਲੀਮੈਂਟਸ ਦੇ ਐਟੋਮਿਕ ਮਾਸ ਦਾ ਅਰਿਥਮੈਟਿਕ ਮੀਨ ਕੱਢੀਏ ਤਾਂ ਇਹ 88.5 ਹੋਵੇਗਾ, ਜੋ ਕਿ ਮਿਡਲ ਐਲੀਮੈਂਟ ਸਟ੍ਰੋਂਸ਼ੀਅਮ ਦੇ ਐਟੋਮਿਕ ਮਾਸ ਦੇ ਲਗਭਗ ਬਰਾਬਰ ਹੈ।
Drawbacks of
Dubreiner's triads.
Main drawback of this theory was that the concept of triad can be applied only to limited number of elements. Since he failed to arrange then known all elements in the form of triads, his attempt at classification was not very successful. Newland's law of octaves. In 1865, English chemist John Alexander Newlands had given this law. It states that when the lighter elements were arranged in order of their increasing atomic weights, the properties of every eighth element were similar to those of the first one, like the eighth note of a musical scale. This concept was known as Newland's law of octaves.
ਜਿਸ ਤਰ੍ਹਾਂ ਸੰਗੀਤਕ ਸਰਗਮ ਵਿੱਚ ਪਹਿਲੇ ਸਾਹ ਤੋਂ 8ਵੀਂ ਪੋਜੀਸ਼ਨ ਤੇ ਸਾਹ ਰਿਪੀਟ ਹੁੰਦਾ ਹੈ, ਇਸੇ ਤਰ੍ਹਾਂ ਪੀਰੀਓਡਿਕ ਟੇਬਲ ਵਿੱਚ ਲੀਥੀਅਮ ਤੋਂ 8ਵਾਂ ਐਲੀਮੈਂਟ ਸੋਡੀਅਮ ਹੈ ਅਤੇ ਸੋਡੀਅਮ ਤੋਂ 8ਵਾਂ ਐਲੀਮੈਂਟ ਪੋਟਾਸ਼ੀਅਮ ਹੈ। ਸੋਡੀਅਮ ਅਤੇ ਪੋਟਾਸ਼ੀਅਮ ਲੀਥੀਅਮ ਨਾਲ ਕੈਮੀਕਲ ਪ੍ਰੋਪਰਟੀਜ਼ ਵਜੋਂ ਮੇਲ ਖਾਂਦੇ ਹਨ। A gap of 7 elements exists between the positions of lithium and sodium, and similar gap is present between sodium and potassium. These three elements arranged vertically resemble in properties.
Defects of law of octaves. This law could be best applied only up to the element calcium. Newly discovered man-made elements could not fit into the octave structure. When elements were arranged in the increasing order of their atomic masses, the feature of periodicity of similar properties of the every eighth element was not successful with the heavier elements. With the discovery of the noble gas elements, the above sequence of elements was disturbed and finally the arrangement lost its validity. As the properties of the every eighth element was no longer similar to the elements lying exactly above it in the same group.
Lothar-Meyer arrangement.
In 1869,
Lothar-Meyer,
a German chemist, studied the physical properties of various elements by plotting a graph between atomic volumes and atomic weights of the elements. He observed that the elements with similar properties had occupied similar positions on the curve. In the graph, atomic masses of the elements were taken along the x-axis, whereas atomic volumes of the elements were taken along the y-axis.
Observations. The most electropositive alkali metals like sodium, potassium and rubidium occupy the top position on the curve. The less electropositive alkaline metals like beryllium, magnesium, and calcium occupy the descending positions on the curve. The electronegative elements like fluorine, chlorine, and bromine occupy the ascending positions on the curve.
On the basis of these observations,
Lothar-Meyer
proposed that physical properties of the elements are the periodic function of their atomic weights.
Dmitry Ivanovich Mendeleev, 1834 to 1907. Mendeleev is called as the father of the periodic table. When Mendeleev had started his work on classification of elements, only 63 elements were known. He carefully examined the relationship between atomic weights of elements and their physical and chemical properties. Mendeleev mainly concentrated on the compounds formed by the elements with hydrogen and oxygen. He grouped together the elements having similar physical and chemical properties. He found that most of elements automatically got arranged in order of their increasing atomic weights. He also observed that there occurs recurrence of elements with similar physical and chemical properties after certain regular intervals.
In 1869, Mendeleev had given a law known as Mendeleev's periodic law. It states the physical and chemical properties of the elements are periodic functions of their atomic weights. When the elements are arranged in the order of their increasing atomic weights, elements with similar properties are repeated after certain regular intervals. This repetition of properties of elements after certain regular intervals is called periodicity of properties.
In the Mendeleev's periodic table, elements were arranged in 6 horizontal rows and 9 vertical columns. These elements were arranged according to their increasing atomic weights in such a way that the elements with similar properties were kept in the same vertical column. He realized that some of the elements did not fit into his scheme of classification. He ignored the order of atomic weights and placed the elements with similar properties together. These vertical column or groups were named in Roman numerals as 0, 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, and 8th.
Group 1st to 7th were
Again divided into subgroups A and B. The elements lying on the left-hand side of each group were representing to subgroup A. The elements lying on the right-hand side of each group were representing to subgroup B. Group 8 had total 9 elements arranged in 3 sets, each containing 3 elements. Group 0 was having no subgroup. It has only one column for inert gases. It has 6 periods or horizontal rows.
He proposed that some of elements were still undiscovered and therefore left several gaps in the table. For example, both gallium and germanium were unknown at the time when Mendeleev published his periodic table. he left the gap under aluminium and under silicon and called these elements Aka aluminium and Aka silicon. Mendeleev predicted not only the existence of gallium and germanium but also described some of their general physical properties. These elements were discovered later. Significance of Mendeleev's periodic table. It allows the systematic study of the elements and their compounds. In simple words, we can say that if we know about the properties of one element of a group, we can easily predict properties of other elements of the same group. Mendeleev had left some gaps for the undiscovered elements in the periodic table. However, properties of these elements could be predicted in advance from their expected positions. These elements were discovered later.
Students, it is time to look at the gap under aluminium and a gap under silicon in the shown periodic table. Can you recall names of these elements? Yes, these elements are Aka aluminium and Aka silicon. These were later on named as gallium and germanium. Mendeleev not only predicted the existence of gallium and germanium, but also described some of their general physical properties. These elements were discovered later.
Mendeleev's periodic table was also helpful in the correction of atomic weights of some elements with the help of their expected positions and properties. Let us take an example to clear the concept. Initially, atomic weight of beryllium was assigned as 13.5 by multiplying its equivalent weight 4.5 and its wrongly calculated valency 3. If it was correct, it should be placed between carbon and nitrogen having atomic weights 12 and 14. But the properties of beryllium are similar to the elements magnesium and calcium, which were assigned at position 2nd A. Therefore, Mendeleev had assigned valency 2 to beryllium. As per valency 2, value of its atomic weight comes out to be 4.5 into 2 equals to 9. Drawbacks. Anomalous pairs of elements. Some elements having higher atomic weight precede the elements having lower atomic weight. For example, iodine having low atomic weight than tellurium was placed in 7th group. It was so because of its resemblance with fluorine, chlorine, bromine. That's why it was placed in 7th group. Mendeleev failed to explain anomalous position of hydrogen. Hydrogen was placed in group 1st A, whereas it resembles with the elements of group 1st A and group 7th. He failed to explain position of isotopes in the periodic table. According to Mendeleev's opinion, isotopes of an element should be placed at different place in the periodic table, but only one place was allotted for isotopes of an element in the periodic table. Some dissimilar elements were grouped together. For example, the alkali metals such as lithium, sodium and potassium of group 1st A are grouped together with coinage metals like copper, silver, gold of group 1st B, though their properties are quite different, while some similar elements were placed in different groups. Chemically, similar elements like copper of group 1st B and mercury of group 2nd B has been placed in different groups. no proper position of 9 elements of group 8th was decided. The elements were arranged in triad without justification. It failed to explain why the elements placed in a particular group show resemblance in their properties.
Henry Moseley, 1887 to 1915। Henry Moseley एक English physicist ਸੀ। He measured the frequencies of X-rays emitted by metals when bombarded with high-speed electrons. He discovered that the square root of the frequency of the X-rays emitted by metal is proportional to the atomic number and not atomic weight of the atom of that metal। 1913 ਵਿੱਚ ਇੱਕ ਇੰਗਲਿਸ਼ ਫਿਜ਼ਿਸਿਸਟ ਹੈਨਰੀ ਮੌਸਲੇ ਨੇ ਐਲੀਮੈਂਟਸ ਦੇ ਐਕਸ-ਰੇ ਸਪੈਕਟਰਾ ਦੇ ਕੈਰੈਕਟਰਿਸਟਿਕਸ ਨੂੰ ਆਬਜ਼ਰਵ ਕੀਤਾ। ਉਸਨੇ ਇਹ ਆਬਜ਼ਰਵ ਕੀਤਾ ਕਿ ਜੇਕਰ ਐਟੋਮਿਕ ਨੰਬਰ ਆਫ ਡਿਫਰੈਂਟ ਮੈਟਲਸ ਦੇ ਅਗੇਂਸਟ ਅੰਡਰ ਰੂਟ ਨਿਊ ਜਾਂ ਸਕੁਏਅਰ ਰੂਟ ਆਫ ਫ੍ਰੀਕੁਐਂਸੀ ਨੂੰ ਇੱਕ ਗ੍ਰਾਫ ਤੇ ਪਲਾਟ ਕਰੀਏ ਤਾਂ ਇੱਕ ਸਟ੍ਰੇਟ ਲਾਈਨ ਪ੍ਰਾਪਤ ਹੋਵੇਗੀ। But it was not obtained when the graph was plotted between square root of frequency against atomic mass of metals. Hence, it was proved that atomic number is the more fundamental property of an atom than its atomic mass. Therefore, atomic number must form the basis of classification of the elements in periodic table. He gave a modern periodic law.
Modern periodic law. It states the physical and chemical properties of the elements are a periodic function of their atomic numbers. Nomenclature of elements with atomic number more than 100. The naming of elements with atomic number more than 100 has been done by applying IUPAC rules. IUPAC is an organization named as International Union of Pure and Applied Chemistry. The main points of this nomenclature are: the names are derived directly from the atomic numbers using numerical roots for 0 and numbers from 1 to 9 and adding the suffix "-ium". A strange mixture of Latin and Greek roots has been chosen to ensure that the symbols are all different. In certain cases, the names are shortened. For example, bi-ium and tri-ium are shortened to bium and trium, and N-nil is shortened to anil. The symbol of the element is then obtained from the first letters of the roots of numbers which make up the atomic number of the element. Let us look at the table having digit, name and abbreviation for the elements.
Digit 0 ਨੂੰ nil ਦਾ ਨਾਂ ਦਿੱਤਾ ਗਿਆ ਹੈ ਅਤੇ ਇਸ ਦੀ abbreviation N ਹੈ। Digit 1 ਨੂੰ an ਦਾ ਨਾਂ ਦਿੱਤਾ ਗਿਆ ਹੈ ਅਤੇ ਇਸ ਦੀ abbreviation U ਹੈ। Digit 2 ਨੂੰ by ਦਾ ਨਾਂ ਦਿੱਤਾ ਗਿਆ ਹੈ ਅਤੇ ਇਸ ਦੀ abbreviation B ਹੈ। Digit 3 ਨੂੰ try ਦਾ ਨਾਂ ਦਿੱਤਾ ਗਿਆ ਹੈ ਅਤੇ ਇਸ ਦੀ abbreviation T ਹੈ। Digit 4 ਨੂੰ quad ਦਾ ਨਾਂ ਦਿੱਤਾ ਗਿਆ ਹੈ ਅਤੇ ਇਸ ਦੀ abbreviation Q ਹੈ। Digit 5 ਨੂੰ pent ਦਾ ਨਾਂ ਦਿੱਤਾ ਗਿਆ ਹੈ ਅਤੇ ਇਸ ਦੀ abbreviation P ਹੈ। Digit 6 ਨੂੰ hex ਦਾ ਨਾਂ ਦਿੱਤਾ ਗਿਆ ਹੈ ਅਤੇ ਇਸ ਦੀ abbreviation H ਹੈ। Digit 7 ਨੂੰ sept ਦਾ ਨਾਂ ਦਿੱਤਾ ਗਿਆ ਹੈ ਅਤੇ ਇਸ ਦੀ abbreviation S ਹੈ। ਡਿਜਿਟ 8 ਨੂੰ ऑक्ट ਦਾ ਨਾਂ ਦਿੱਤਾ ਗਿਆ ਹੈ ਅਤੇ ਇਸ ਦੀ ਐਬਰੀਵੀਏਸ਼ਨ O ਹੈ। ਡਿਜਿਟ 9 ਨੂੰ N ਦਾ ਨਾਂ ਦਿੱਤਾ ਗਿਆ ਹੈ ਅਤੇ ਇਸ ਦੀ ਐਬਰੀਵੀਏਸ਼ਨ E ਹੈ।
The recommended and official names of some super heavy elements with atomic number Z more than 100 are shown in the table on the screen.
ਕੁਝ ਐਲੀਮੈਂਟਸ ਦੇ ਐਟੋਮਿਕ ਨੰਬਰ Z, recommended name, symbol, IUPAC official name ਅਤੇ IUPAC symbol ਨੂੰ ਇੱਥੇ ਵਿਖਾਇਆ ਗਿਆ ਹੈ। ਇੱਥੇ 101 ਤੋਂ 118 ਤੱਕ ਐਟੋਮਿਕ ਨੰਬਰ ਵਾਲੇ ਐਲੀਮੈਂਟਸ ਨੂੰ ਵੀ ਵਿਖਾਇਆ ਗਿਆ ਹੈ। ਐਲੀਮੈਂਟ ਜਿਸ ਦਾ ਐਟੋਮਿਕ ਨੰਬਰ 101 ਹੈ ਉਸ ਦਾ ਨਾਂ ਅਨਿਲਨੀਅਮ ਹੈ ਅਤੇ ਇਸ ਦਾ ਸੰਕੇਤ UNU ਹੈ। ਇਸ ਦਾ IUPAC ਨਾਂ MENDLEEV'S ਹੈ ਅਤੇ ਇਸ ਦਾ IUPAC ਸਿੰਬਲ MD ਹੈ। (102) ਐਟੋਮਿਕ ਨੰਬਰ ਵਾਲੇ ਐਲੀਮੈਂਟ ਦਾ ਨਾਂ ਅਨਿਲਬਾਇਮ ਹੈ ਅਤੇ ਇਸ ਦਾ ਸਿੰਬਲ UNB ਹੈ। ਇਸ ਦਾ IUPAC ਨਾਂ ਨੋਬੇਲੀਅਮ ਹੈ ਅਤੇ ਇਸ ਦਾ IUPAC ਸਿੰਬਲ NO ਹੈ। ਐਟੋਮਿਕ ਨੰਬਰ 103 ਵਾਲੇ ਐਲੀਮੈਂਟ ਦਾ ਨਾਂ ਅਨਿਲਟ੍ਰਾਇਮ ਅਤੇ ਸਿੰਬਲ UNT ਹੈ। ਇਸ ਦਾ IUPAC ਨਾਂ ਲੋਰੈਂਸੀਅਮ ਅਤੇ IUPAC ਸਿੰਬਲ LR ਹੈ। ਐਟੋਮਿਕ ਨੰਬਰ 104 ਵਾਲੇ ਐਲੀਮੈਂਟ ਦਾ ਨਾਂ ਅਨਿਲਕੁਆਡੀਅਮ ਹੈ ਅਤੇ ਸਿੰਬਲ UNQ ਹੈ। ਇਸ ਦਾ IUPAC ਨਾਂ ਰਦਰਫੋਰਡੀਅਮ ਅਤੇ IUPAC ਸਿੰਬਲ RF ਹੈ। 105 ਐਟੋਮਿਕ ਨੰਬਰ ਵਾਲੇ ਐਲੀਮੈਂਟ ਦਾ ਨਾਂ ਅਨਿਲਪੈਂਟੀਅਮ ਹੈ ਅਤੇ ਇਸ ਦਾ ਸਿੰਬਲ UNP ਹੈ। ਇਸ ਦਾ IUPAC ਨਾਂ ਡਬਨੀਅਮ ਅਤੇ IUPAC ਸਿੰਬਲ DB ਹੈ। ਬਾਕੀ ਐਲੀਮੈਂਟਸ ਦੇ ਐਟੋਮਿਕ ਨੰਬਰ 106 ਤੋਂ 118 ਹਨ। recommended name, symbol, IUPAC official name ਅਤੇ IUPAC ਸਿੰਬਲ ਨੂੰ ਤੁਸੀਂ ਸਕਰੀਨ ਤੇ ਵੇਖ ਸਕਦੇ ਹੋ।
Students, I hope that you have enjoyed today's lesson 2 as much as I did. Now let me ask few questions to check what you have absorbed from the topic. So, my first question is, what would be IUPAC names and symbols for the element with atomic numbers 111, 113, 115, 117, 118? And the answer is, IUPAC name of the element having atomic number 111 is Ununtrium and its symbol is UUU. Its IUPAC symbol is RG. IUPAC name of the element having atomic number 113 is Ununtrium and its symbol is UUT. IUPAC name of the element having atomic number 115 is Ununpentium and its symbol is UUP. IUPAC name of the element having atomic number 117 is Ununseptium, and its symbol is UUS. IUPAC name of the element having atomic number 118 is Ununtrium, and its symbol is UUO. I hope you have enjoyed the lesson. Hope this episode will help you in better understanding of this topic. See you in the next class. Till then, bye.